Hello everyone, I'm Bill Wolpin, the Associate Publisher and Editorial Director at American City and County, and your moderator for today's webinar, UL 738 Flue Gas Venting to Safeguard Against the Dangers of Carbon Monoxide. This webinar is brought to you by IPEX. Before we get started, let me explain how you can get the most out of this event. To improve your viewing and listening experience, you can move your webcast windows around by dragging on the title bar or resize them by clicking on their lower right corner. At the bottom of your screen, you'll find multiple application widgets. In fact, a copy of today's slide deck is available for download in the Resource List application. The logos you see on your console, including the IPEX logo, are hyperlinked. If at any point you would like to visit the corresponding website, you can click on any logo and a new window will appear. This will not take you out of the webinar. Of course, we welcome your questions about our topic and will answer as many as we can following the presentation. But feel free to submit yours to the queue at any time. Just type it into the Q&A window on the left-hand side of your screen and hit the Submit button. Please be aware that today's session is being recorded and will be available for on-demand viewing. You'll be notified by email when that archive is available. Now let me introduce today's speaker, Matthew Tucci. Matthew is a Market Development Specialist, Flue Gas Venting at IPEX USA LLC. His primary focus within IPEX is planning and implementing market development activities, such as educating market stakeholders, participating in FGV codes and standards committees, and working with customers. You can find out more information about Matthew by clicking on the Speaker Bio widget at the bottom of your screen. With that, let's all get started. Matthew, the floor is yours.
Thanks. Hi, everybody. So my name is Matthew Tucci. I'm a Market Development Specialist for IPEX. So today we're going to be talking about flue gas venting, certified flue gas venting, and comparing it to standard venting products. So a little bit about IPEX, if you aren't familiar with IPEX and who we are. We're a thermoplastic piping manufacturer. We manufacture everything from hot and cold potable water systems to municipal pipes, C900 and C909, industrial pipes, Schedule 40, Schedule 80 PVC and CPVC, industrial ABS pipe, airline pipe, double containment pipe, electrical conduit, and among other things. And the reason I'm letting you guys know this is that at any one point we could have taken one of these products and marketed towards flue gas venting. But the idea with a certified product and a certified flue gas venting product is that you have a product that was designed and intended for that specific application. It's not another product that is just being used in that application. So looking at the agenda today, we'll be starting off very broad. What is flue gas? We'll be talking about what's in flue gas, why it's important to have a proper venting system. We'll get into venting history, so what products were used in the past, what products are currently used. We'll talk about why they were used, and then we'll get into some codes and standards. So we'll talk about the ASTM standards, the CSA standards, so those are product standards. We'll talk about the model codes, and we'll talk about the updates that have been made to those, and we'll talk about UL 1738, so the flue gas venting standard, how that's incorporated into the model codes, and then we'll get into some design considerations, and we'll look at the market today, what's available in the market, and we'll compare some of the products that are currently available. We're going to have a Q&A at the very end, so if you have any questions, feel free to type them in and we'll get to them at the end. We'll save some time for those. So starting off broadly, what is flue gas? Flue gas is a byproduct of incomplete combustion. So a gas burning appliance, whether that is a fireplace, a furnace, a boiler, a water heater, whatever it might be, when you're burning gas, you have byproducts. And the byproducts of flue gas are going to be mainly carbon monoxide and water vapor. Carbon monoxide, you can't see it, you can't smell it, and it's very difficult to detect, and it's toxic. So you need to have a proper venting system so that this doesn't leak into the residence or commercial building or whatever it might be. So flue gas consists mainly of carbon monoxide and water vapor. and it needs to be vented safely. That's the main purpose of a flue gas system. Looking at the gas-fired appliances, they're divided into 4 venting categories. You have category 1, which is negative pressure non-condensing. You have category 2, which is negative pressure condensing. You have category 3, which is positive pressure non-condensing, and you have category 4, which is positive pressure condensing. Today we're going to be speaking mainly about category 2 and category 4 appliances, so that is negative and positive pressure both condensing, so typically higher efficiency appliances. Looking at venting history. So currently today, when you are venting an appliance, the appliance manufacturer is going to specify which materials are approved for venting with their appliance, obviously in conjunction with the local codes. When these appliances were first designed and brought to market, they needed, they were burning gas products, and they needed to vent them properly. But there was no venting specific material, there was no venting specific standard for them to use. So what did they do? They did what any reasonable person would have done. They used the products that were most readily available. So they used PVC Schedule 40 plumbing pipe. That's what the people installing the appliances had in their truck. That's what the distributors had most readily available. That was the cheapest thing that they could use. That's what they used. So on the bottom here, you'll see some typical approved materials for venting for a water heater. You'll see PVC, CPVC, and you'll have various standards to ASTM and CSA, basically for plumbing products. Well, on the other side, you have the manufacturers of the plumbing pipe and fitting. So, those products that they're using to vent carbon monoxide and the flue gases were actually intended for plumbing applications. So while the applications may seem similar, they are different. In a flue gas application, you have heat cycling with your appliance turning on and off. You have it being exposed to condensate, which can be acidic. You can have UV light exposure. So these are things that typically a plumbing system won't be exposed to. So the plumbing pipe and fitting manufacturers couldn't endorse or promote or warranty their products for flue gas applications because they hadn't been tested or designed for that application. So basically they were being used for an application that they had never designed the product for. So looking at the model codes and the standards now for the products, well, the plumbing products are made to ASTM standards. And ASTM, these are plumbing standards, and they're commonly referenced in the appliance manuals because when they were writing the appliance manuals, they needed standards to reference, and that's what the plumbing products were made to. So that's what the standards they listed. So these are some common ASTM standards that you'll see in an appliance manual. You'll see ASTM D2665 for PVC drain, waste, and vent. You'll see ASTM D1785 for Schedule 40, 80, 120. You'll see D2241 for SDR. Those are PVC standards. And then for CPVC, you'll see 2846, F441, and F442. For hot and cold potable water, Schedule 40 and 80, and SDR, and then sometimes you even might see ABS. Well, these are the standards that are referenced. It doesn't change the fact that these standards are referenced for and written for fluid handling applications. So as a result, ASTM, they have a technical committee, and they, while they are, consist of industry stakeholders for the plumbing applications, and they are well versed in plumbing. They don't really have much experience for flue gas applications, so they had to include these notes in the scope of the standards that basically state that this is the note that was included in ASTM 1785, and something similar or the same note was added to all the standards we just mentioned. And basically what it says is the standard specifies dimensional, performance, and test requirements for plumbing and fluid handling applications only. It does not include provisions for the use of these products for venting of combustion gases. UL 1738 is a standard that does include specific testing and marking requirements for flue gas venting products, including PVC. So right in the standards that are being referenced, you have this note that's saying these products really shouldn't be used for flue gas applications. They make no provisions for it, and they reference UL 1738, which is a flue gas venting standard for metallic and non-metallic materials, and we'll get into that standard in a bit. CSA, which is also widely accepted and trusted standard. They included the following note in their B1800 thermoplastic non-pressure piping, technical book. And what the note says is the standard does not specify requirements for venting of combustion gases. In Canada, ULC S636 specifies testing and marking requirements for pipe fittings and accessories intended for venting of combustion gases. In the United States, UL 1738 specifies testing and marking requirements for pipe fittings and accessories intended for venting of combustion gases. So both ASTM and CSA are now stating these notes that say, these products aren't intended and these standards aren't intended for flue gas applications, and they reference UL 1738. Now, there's two model codes for venting of combustion gases, venting appliances. You have the National Fire Protection Association, Code 54, which is the National Fuel Gas Code. So you have NFPA 54, and you have the International Fuel Gas Code, which is the IFGC. So both were updated in 2018 on their latest code cycle, and they include the notes in Chapter 12, Section 5, which is venting appliances and types of venting systems to be used. They included the notes in orange there. And what they say is, where plastic piping is used to vent an appliance, the appliance shall be listed for use with such venting materials, and the appliance manufacturer's installation instructions shall identify the specific plastic piping material. So the appliance needs to be listed for the venting material, and the installation instructions need to identify the specific piping material. It goes on to say the plastic pipe venting material shall be labeled in accordance with the product standards specified by the appliance manufacturer, which is the ASTM standards already listed in their instructions. And then the note in orange was added that says, or shall be listed and labeled in accordance with UL 1738. So this was in the NFPA 54, the National Fuel Gas Code for 2018, and a similar, mirror code in the International Fuel Gas Code was added, Chapter 5, Section 3, basically saying the same thing. So what does this all mean? Well, the appliance manufacturers will still specify suitable materials for venting with their appliances. So the appliance manufacturers know their appliance, they're going to choose what venting material they want. Well, it now gives, authorities having jurisdictions, whether that's inspectors or the city or the county, and engineers, installers, it gives them a choice to now use the products listed to ASTM plumbing standards or to use products certified to UL 1738. The ASTM plumbing standards and the CSA standards state they have, do not specify requirements for flue gas venting applications. So, in our opinion, and in the opinion of, people that are understanding the issue, using a product that's actually intended and certified for the application is the right thing to do, especially in an application where you're venting carbon monoxide, it's a toxic gas, in comparison to a fluid application where, if you have a leak, if a product fails, you have, water damage, but typically you're not having any loss of life or anything close to that. The other standard I wanted to talk about is the ANSI Z21 standard. So this is, appliances also have their own standards, which are the ANSI standards. And this chart here is from one of the water heater standards, and it basically says the maximum allowable temperatures of typical non-metallic vent materials used in water heaters. So which is fine. If you look at the first column, you'll see different materials for venting: PVC, CPVC, ABS. The second column is nomenclature, so you'll have Schedule 40, 80 is basically your dimensions. And then you have your fourth column, which is your ASTM or your CSA standards that these products are made to. Now, if you look at the second column, you have your heat deflection temperature. Now, a heat deflection temperature is the temperature that a material will begin to deflect under a specific load. So they subject the material to a specific load, they increase the temperature, and the temperature that it deflects at is the temperature basically that it's about to fail at. And for PVC, you have 158, for CPVC, 212, ABS, 180, and these are plumbing, PVC, CPVC, and ABS. The issue is that by reading the title of the chart, you have maximum allowable temperatures of typical non-metallic vent material. So you will think by looking at this chart that 158 is the maximum allowable temperature of PVC, when in reality that's the temperature that the material is going to fail at. Regular PVC for plumbing is rated to 140 degrees. The 18-degree difference between that and the heat deflection temperature is a safety factor built in by the manufacturer. But this chart is misleading, and it allows PVC, CPVC, ABS to be used basically until they're failing. So not only are they using products that were never intended for the application, they're basically using them until failure. which is an issue in and of itself. So looking at the model codes and kind of wrapping that all up, there's a clear disconnect between the appliance manufacturers, the vent manufacturers, and the model codes and standards. And the solution that people are becoming much more aware of and gravitating to is UL 1738. And we're going to get into the standard right now. But basically, UL 1738 allows for the appliance manufacturers to continue specifying their preferred venting material. The standard does not specify materials. If you can pass the test, then you can become certified. The certified venting materials will replace plumbing products which were never intended for the application or warranted by their manufacturers. And having a uniform standard also eliminates the disorganization and confusion that comes with different jurisdictions having different requirements. One jurisdiction might require or allow for PVC and CPVC. One might say no to PVC. One might say no to CPVC. By having one standard, it's much more clear for inspectors. They know what is required. It's much more clear for contractors and people installing because they know the standards that they need to meet. They know the products they need to use. It elevates the level of installation and it elevates the level of inspection for everybody because it's clear what's expected. So looking at UL 1738, to start off, we'll talk about some typical venting issues. So one that we see quite often is, venting that is exceeding flue gas temperature limits. So this is highlighted, this picture here highlights a few things. One is, you have PVC, plumbing PVC there on the left and on the right. One has turned brown, and that's actually the result of a combination of things. One is exposure to UV light, and one is too high flue temperatures. The ASTM standards that these plumbing products are made to don't test for UV light, they don't test for elevated temperatures, or any combination of them. The other thing that it highlights is that when you're using plumbing products for the application, you could have one manufacturer of pipe, you could have a different manufacturer of fittings, you could have multiple manufacturers of pipe and fittings. And although plumbing PVC is relatively standardized, you're still going to have slightly different blends of PVC formulations. And one might be slightly more UV resistant, one might be slightly less. You have, you can see the pipe on the right is much more white than the fittings, which are more of a yellow tinge. So you could have different formulations for fittings and pipe as well, each with slightly different characteristics that one might be able to hold up and one might not be able to hold up. So you have no consistency with your pipes and fittings. You have no, minimum level of performance. The other is environmental conditioning. So what you see there are environmental stress cracks. So they could be caused by UV light. They could be caused by condensate, which is acidic. They could be caused by, the material being exposed to these things, and then, we all know that the material is not handled with white gloves in the field. So it could be, low temperature applications where the pipe becomes brittle and then becomes hit with something. The ASTM standards don't test for any of these things, and these are things that we see failing all the time. The other is installation error. So one thing that comes up is that a standard flue gas venting standard is not going to improve the level of installation. I would say I disagree with that because part of the UL 1738 standard is that the product must come with a comprehensive installation guide. And what the installation guide outlines is proper solvent cementing issues, or proper installation if you have gaskets, or proper installation regardless of your method of joining. It outlines proper restraints and support, proper terminations, whether that's through a roof or through a wall, how to account for expansion and contraction, among other things. So rather than right now with plumbing products where installers, they're using plumbing products but they're not supported by their manufacturer, if they have someone to turn to, there's not going to be installation instructions, there's not going to be much support there. Now they have, with every job that they do, they have proper installation guide. They have someone to reference, they have someone to turn to, and if they have a question that's not in the installation guide, they have someone that they can actually pick up the phone and call and talk to. So having a standard actually will increase your level of installation overall. And the last is a lack of product support. So the issue with not having a system that's actually designed and intended for that application, you have no specialized fittings. So what you see here is someone that needed to test their flue gas temperature after the appliance was commissioned. And what they did is they drilled into the PVC pipe, they tested it, and they need to plug the hole, so they did that, which is obviously not a permanent solution to block flue gas. So you have no specialized fittings, and you also have no warranty. So all of the major PVC manufacturers have stated that they do not endorse their product or promote or warranty their product for flue gas applications. So you have no warranty when you use plumbing products in flue gas applications. With a certified product, typically you have 10 years of warranty. So not only are you having all this support during installation, but you have a product that the manufacturer is actually going to stand behind. So looking at UL 1738 specifically, at its base, it is a standard for venting systems of gas burning appliances, categories 2, 3, and 4. It covers both metallic and non-metallic materials, and includes over 50 material and system performance tests. And we'll talk about some key material tests and key system performance tests in a second. The standard does not specify dimensions, and it does not specify material. So you can make Schedule 40, you can make Schedule 80 pipe, you can make SDR pipe, regardless of your dimensions, so for your pipe or your fittings, as long as the system can pass the material and the system performance test, you can have a certified product. And also, among all of the standards out there, UL 1738 does provide the highest possible chance of success. It is the most stringent flue gas venting application that we have available, and that we have products that are able to be made to. Another thing I'd like to note is that UL 1738 is not a new standard that was recently written. It's actually been around since the 1980s, and for a long time, metals were the only product that could be made to the standard because the technology in manufacturing and processing for plastics was just not there yet. So for a long time, the plastics just could not meet the standard, and it was very difficult. And we'll talk about some of the standards or some of the tests included in the standard that made it so difficult. But recently, there's been multiple manufacturers that have the technology now to produce plastics to the venting standard. So now you actually have multiple materials from multiple manufacturers available for flue gas venting, specifically designed for that application, and you're starting to see more and more people switch over to that because it is a safer option. So looking at some key tests, we'll talk about some key material tests. The first that I want to talk about is a temperature structure test, which basically subjects the material to 70 degrees above the rated temperature that the system is going to be rated to. It's held until steady state, and then the material must still be acceptable for its intended use, which is flue gas application. This, ensures that as appliances age, there's a tendency for some of them to run hot, have higher flue temperatures than originally intended. This ensures that if this does occur with a certified system, that the system is going to be able to withstand that higher temperature, and it's not going to become brittle or break or melt or anything along those lines. So you have a large safety factor available if the appliance does run hot. The other is a low temperature test. So, there is a tendency for plastics more than metals to become brittle at low temperatures. So there's a low temperature test associated with UL 1738. And what it does is it subjects the material to -4 degrees Fahrenheit for 5 hours. You have pipe that is dropped on a concrete floor twice, and it's very specific for the test. And this ensures that you're not going to have any shattering or chipping or cracking on the end of the pipe that might be missed and then installed. And then if this happens in a fluid handling application, in a plumbing application, you would notice right away you would have a water leak. In a flue gas application, you might not notice right away because you have carbon monoxide that you can't see it, you can't smell it. So if you have a leak, it might be too late by the time you actually notice there is an issue there. So you have the metals or the plastics that are certified to 1738 are going to be able to withstand those low temperature tests. The other is conditioning. So you have multiple conditioning tests. So you have elevated temperature, you have light and water, which subjects the material to UV testing. you have condensate, you have high acid. So the material is subjected and conditioned to all of these different conditioning tests. And then following that, you have tensile tests, you have impact tests, you have crush resistance, you have flammability. These are all tested, and the material must maintain a percentage of the unconditioned test results. And what this does, and the point of this conditioning test, is that even after, sure, the material when brand new can withstand flue gas application, but after it's been conditioned over the life of the system, it's going to be exposed to different things. After it's been conditioned to all these different things, can it still hold up? And the UL 1738 standard ensures that it can. And the last material test that I want to talk about is a heat deflection temperature. Like I mentioned before, a heat deflection temperature is a temperature that the material is going to fail under a specific load. So there is a heat deflection temperature test basically for polymer materials, so plastics, PVC, CPVC, polypropylene. The material heat deflection temperature needs to be at least 18 degrees higher than the system rated temperature. So if you rate it for 140, the heat deflection temperature needs to be 158. And this guarantees a minimum level of performance for the heat deflection temperature and a guaranteed safety factor. Looking at some system performance tests, you have your joint sealing compound test, which is, going back to the elevated temperature, is the equivalent test for the joint sealing compound. So whether that is solvent cement, or a gasket or a flange kit, whatever it might be, whatever your method of joining is, the venting assembly is connected to a heat-producing assembly and subjected to 70 degrees above the rated temperature for 3 hours. The joint sealing compound cannot crack or soften or melt or show any evidence of deterioration. So not only are you testing the material, but you're also testing the joint sealing compound to ensure that your joints are going to, stand up during those elevated temperatures if an appliance runs hot. The other is a joint tightness test. So this is specifically important for thermoplastics that experience expansion and contraction. So even if the material is going to come with a comprehensive installation guide, but say it doesn't get followed properly, and the person installing doesn't account for expansion and contraction that they should, this test subjects the joints to 25 foot-pounds of torque, so that if those joints experience the expansion and contraction and they're not accounted for properly in the system, those joints that are experiencing that force, the joint tightness test guarantees that you're going to have or ensures that you're going to have a joint that's going to be able to withstand those forces. The other and the last system key test that I want to talk about is the strength test for non-metallic vent systems. So you have a heat-producing assembly, and you have a flue gas setup, and the gas appliance is cycled on and off, 10 minutes on, 15 minutes off, for 12,000 cycles. And what that does is, after that cycle, it simulates 10 years of use for the flue gas venting system. Following the 12,000 cycles, you can't have any cracking or evidence of condensate leaking or damage to the system. And following that inspection, they take the system, they break it apart, and they subject it to some force tests. And that, again, ensures that even after the life of the system, even after the 10 years of simulated use, that the system will still be able to hold up to any forces that it might be subjected to. So not only is the system tested for flue gas applications while it's new, even at the end of the system, you're going to know that your system is going to be fit for use. Some other things that are important with the UL 1738 standard are the marking requirements. So UL 1738 requires specific marking requirements for certified products. Each stick of pipe, each fitting require a carbon monoxide warning label, basically saying there's a risk of carbon monoxide poisoning and a risk of fire if it's improperly installed. Make sure you follow all caution warnings and instructions. Additionally, you're going to have on the print lines of pipe, you're going to have a temperature rating, you're going to have the appliance categories that it's fit for, minimum clearance to combustible materials, and the manufacturer's name and date. So these products are easily identifiable. They're not going to be confused with plumbing products. An inspector is going to be able to easily identify these products for what they're actually intended for. The other, which I already previously mentioned, is the installation instructions. So UL 1738 requires instructions be included with the product. This includes methods of support a step-by-step process for installing the venting system, minimum clearance to combustibles, clearance to walls, floors, ceilings, joists, roof construction, and then terminations through the roof, through the wall, how close the terminations can be to each other, and expansion and contraction, among other things. So everybody, that is using this product to install it, or is installing this product, is going to be well aware of what they need to be doing. Obviously, the local codes are going to obviously take first, or be looked at first, but if there is ever a gray area and they need some guidance, there is installation support there for them. And the last additional requirement is no mixing of components. So going back to having multiple different types of pipe, multiple different fitting manufacturers for a plumbing application, the UL 1738 standard requires that there is no different manufacturers. So you need to have pipe, fittings, joining methods, and terminations from a single manufacturer if you want the system to be certified. And this, this improves, the level of installation because you have one type of tolerance from one manufacturer, so you have better chance of having a successful joint. And if anything does go wrong with the joint, with the system, you have one person to call, and they're going to warranty the product because it's actually intended for that application. So, recapping, UL 1738. Going back to the typical venting issues. Exceeding flue gas temperature limits. So you have an elevated temperature test for the material. You have an elevated temperature test for the joint sealing compound that's 70 degrees above the rated temperature. So if an appliance does run hot, you're going to be okay. The other is the environmental conditioning. So we mentioned the conditioning tests. So UV, condensate, high acid, elevated temperature. And then the material is subjected to tensile tests, flammability, crush resistance, as I mentioned. So, these environmental conditioning tests are tested and included in UL 1738. The installation errors. So, while, a standard is never going to guarantee a proper installation, it is going to significantly improve the level of installation because you have everybody on the same page, you have proper installation instructions, and you have manufacturers going out and training inspectors and contractors and people that are using this product every day. And lastly is the lack of product support. So, you have specialized fittings, again, with a certified product, and you have warranty because the product was actually designed and intended for that application. So these are just some key tests that I thought were important. There are over 50 system and performance tests associated with UL 1738. It is a very stringent standard and difficult to pass. And if you're interested, I would encourage you to take a look and take a look at the UL standard a little bit more closely. Looking at precedent for adopting a venting standard. So while it might be a relatively new thing in the United States, in Canada in 2007, the National Building Code mandated that in all venting systems need to be certified to ULC S636. So ULC S636 is a Canadian version of UL 1738. It included PVC, CPVC, polypropylene, stainless steel. It covered all new and retrofit installations and required all installations to use one brand for pipe fittings, cements, and transitions. The appliance manufacturers still got to specify which vent material was approved for their appliance. So they chose their vent material, but whatever venting material they chose, the installer had to use certified venting material. And it immensely improved the installation and reduced failures. And the other thing is carbon monoxide alarms. So for a long time, there was no codes requiring carbon monoxide alarms. Now you see the states in red that do require it, and then the states in orange have local legislation, some that don't have any at all. But a carbon monoxide alarm is not and should not be your first line of defense. You should have a certified venting. You should have proper venting that's actually intended for the application to vent your carbon monoxide out of your house or building, and then you have a carbon monoxide alarm that is there, the second line of defense, in case that fails. I mean, additionally, carbon monoxide alarms they have a certain level of concentration before they actually set the alarm off. And while this concentration for carbon monoxide might be okay for the average person, it can still be harmful to young children and elderly people who are going to be the most vulnerable. So you don't want to wait until there's a failure in your venting system to actually have an alarm go off. You want to have a proper venting system and have the alarm as a backup. Looking at some design considerations, in terms of vent sizing, what vent material should be used, what size that vent should be, the maximum allowable vent length from the vent to the termination, and the equivalent vent length for each fitting. All of these are still going to be decided and chosen by the appliance manufacturer. Going from a plumbing product, uncertified product to a certified product, these aren't going to change. The only difference is now you're going to be using a certified product for the application. So these design considerations aren't going to really have much change associated with them. So they should be consulted with the appliance manufacturer. And then looking at some available products in the market. So to recap quickly, we have UL 1738 is a material and system performance standard. The standard does not specify any materials or dimensional requirements. So currently in the market today, we have PVC, we have polypropylene, and we have metal. Coming soon, at the beginning of next year, will be CPVC certified, flue gas venting material. So looking at each one specifically now. PVC, this is manufactured by IPEX. It is a permanent solvent weld joint system. So in comparison to the current products being used, you're going to have the same method of installation. You're going to have a one-step solvent cement unless you are solvent cementing below freezing. You have Schedule 40 pipe dimensions. You have fittings that are made to ASTM D1785. So these are the same dimensions as your plumbing product. And while the PVC compound used in this system is significantly different, the dimensions are the same. So you're not going to have much change in terms of installation, rather than having improved product support. The system is rated for flue temperatures up to 149 degrees, and it has a 10-year product warranty. And that's what you see right there. Another product that you might see on the market is certified polypropylene. So this is push-fit EPDM gasket joint. One of the benefits of the system is that it's extremely lightweight, so it's easy to transfer. And this is because the wall thicknesses are very thin. So you have approximately 2 millimeters thick walls for the majority of the pipe sizes. And another benefit is that it is rated for flue temperatures up to 230 degrees, and it does come with a 10-year product warranty. They are not permanent joints, so you have a gasket joint, and we'll talk about some of the considerations that you need to consider when installing this product. But it is an option for sure that you will see. And the other is, and the one that's been around for a long time, is metallic, so mainly stainless steel. These can go very large diameter and fittings for pipe up to 48 inches and likely even larger. You'll see push-fit gaskets. You'll see flange joints. You can see even welded systems in some applications, and they can be rated for flue temperatures up to 550 degrees and even larger, depending on if they have a specific coating or if they are for a specific application. And the other product that is coming soon is a certified CPVC, also by IPEX. This is, again, a permanent solvent welded joint, Schedule 40 pipe dimensions, fittings, again, to ASTM D1785. And it does have a flue temperature rating or it is rated for flue temperatures up to 194 degrees. So you'll have PVC for lower temperature applications, and you have CPVC for higher temperature applications up to 194. And again, this does come with a 10-year product warranty. So comparing these products that are available currently and will be available, you have PVC, which is rated for 149. You have CPVC, which is rated for 194. You have polypropylene 230, and metals 550 and even higher. Current size availability, you have 2, 3, and 4 inch for PVC. CPVC again will be launched in 2, 3, and 4 inch, and by the end of I'd say by the end of next year, you'll have PVC and CPVC certified material up to 12 inches. Polypropylene is also available currently from 2 to 12 inches, and you have metallic materials. Basically whatever size is required for the application. In terms of support spacing, you have PVC and CPVC, which is going to be supported the same way that your standard plumbing products would be supported, so that's typically every 5 feet. Looking at polypropylene, because the wall thicknesses are so thin and the material is very lightweight, one of the drawbacks of the material is that you need to support the material every 3.2 feet, basically every 1 meter. And that's because you do have a thin wall and high temperatures, so the material tends to be a little bit softer. And then metallic, you're going to have support spacing, obviously, depending on your size, and that's going to be up to the manufacturer. In terms of joints and your method of joining, PVC and CPVC are going to be one-step solvent cement. Primer will be required when you have solvent cementing below freezing, so in those applications you will require a primer. Polypropylene, typically you have a push-fit gasket, and you have a locking ring to ensure that those gaskets don't come apart. And then metallic, you have either push-fit gasket or some kind of flange system. In terms of startup time, when you are installing the system, PVC and CPVC, they're solvent cement systems, so you're going to need what we call an appliance service time. The appliance service time is the time required from the solvent cement system being installed to the time you can fire up the appliance. Basically allows the joints to cure. Typically that's about anywhere from 30 minutes to about an hour, depending on the temperature. And then for polypropylene, it's not a permanent joint, so you have push-fit gasket, so you don't really have to wait for anything to cure. And same thing with metallic systems. In terms of condensate considerations, PVC and CPVC, they are used, not intended for flue gas applications, but other PVCs and CPVCs are used in water treatment plants and industrial applications every day. So they can handle acids, so you don't really have any condensate considerations there in terms of compatibility. Same thing with polypropylene. You don't have any condensate considerations with the material itself, but the one thing that you do need to consider is that the push-fit gaskets have an EPDM gasket. And depending on the condensate, that is something to consider. The pipe is not plain end to plain end. You have a socket by spigot with no couplings, so the pipe is not bidirectional. The pipe needs to be installed the proper way so that you don't have condensate draining back and sitting on the EPDM gaskets. So that is a consideration there with the polypropylene system. And then for metallics, again, one of the main drawbacks for metallics is that you will have corrosion issues if you have the system exposed to condensate issues. So that's basically a summary of products that are currently available in the market, their sizes, their temperature ratings, their methods of joining, and some insulation and condensate considerations. And then in terms of a summary, so in flue gas applications where failure can result in injury, using products that provide the best chance, using products that are actually intended for that application is the right thing to do. It's the safest choice, and it's a clear choice. The NFPA 54 and the IFGC model codes now recognize UL 1738 as the appropriate flue gas venting application, or flue gas venting standard, and they included it in their 2018 model codes. This gives authorities having jurisdictions, so inspectors, engineers, installers, the state, the county, whoever it might be making those decisions, the options to use certified venting systems rather than ASTM standards. So the ASTM plumbing standards and the CSA standards now include a note stating that they are intended for fluid handling applications only, and they refer to UL 1738 as the appropriate flue gas venting standard. The UL 1738 certified products, still provide the appliance manufacturers the freedom to list whatever venting material they want. Their preferred venting material can still be used, but it does address today's common venting issues like we talked about: elevated temperature, UV, condensate exposure, so environmental conditioning, improper installation. It will improve the level of insulation, and now you have a product warranty and you have specialized fittings. And lastly, certified flue gas venting systems are currently available in multiple materials from multiple manufacturers, and this is only going to increase as time goes on, providing a significant improvement to the current products that are being used today. So that is basically flue gas venting. I think we are going to go into a question and answer period. So thank you for joining me, and I think we are going to do some questions now.
Thank you, Matthew. And to the audience, this is, as you know better than I do, this is a complex subject, and you have Matthew to ask questions to, and there's very little room for error. So I encourage you to ask what questions would be relevant and important to you. But let's go ahead and take a question or two here. We have a few. Matthew, the question is, why is UL 1738 now relevant?
So the standard has been around for a long time. It's been around since 1980s. But when it was first written, it made it extremely difficult for anything but metals to be able to pass the standard. Specifically, the low temperature testing was very, very difficult for plastics to pass. I'd say in the last couple of years, the manufacturing technologies have improved. So, the processing of plastics and the extrusion and the molding of plastic technology has improved to the point where now you can have PVC, you can have CPVC, you have polypropylene that can be made to this standard and can be made with the proper, formulations that can pass the standard. So now you have, for a long time, the issue was you didn't have enough products that could actually meet the standard. So now you have multiple materials from multiple manufacturers that can meet the standard, and is why you're seeing people starting to adopt the standard now.
Gotcha. So another question here, what UL 1738 certified products are in the market today?
Currently you have PVC available from IPEX. You have CPVC that will be available coming out at the beginning of next year. You have a polypropylene push fit system, and then you have a metal systems from multiple manufacturers available in the market.
Okay. I remember you talking a little bit about it, but that might as well be as clear as we can about this. Now, the question here is UL 38 improves the product, but how do you ensure proper installation or address any other issues related to installation?
Yeah, so that goes back to the installation guide. So, a standard is never going to guarantee a proper installation, but when you have proper product support, you have proper installation, you have proper training from the manufacturers for the people installing the product, you have a significantly improved chance of having a good installation. So yeah, you have improved product support, you have specialized fittings. People using this product are going to be much more supported.
Gotcha. Okay, well listen, Matthew, you did a wonderful job. I'd like to thank you for your presentation. I, like other people in the audience, I certainly learned a good deal about this material. We'd also like to thank you as well as IPEX for making today's webinar possible. Know if we didn't answer a question, the speaker will respond to you directly. As a reminder, you're going to receive a follow-up email that will include a link to view a recording of today's presentation. So if you found the event useful, please share it with your colleagues. At the end of the event, a short survey will pop up in your browser window. We'd appreciate it if you would share your feedback on the event, as it'll help us and the sponsor provide the content most interesting and valuable to you. Finally, we all thank you for your time. This is Bill Wolpen, and we look forward to seeing you at the next American City and County webinar.